Recording in progress.
See, some questions are there which we are supposed to discuss in our AC, particularly some parallel circuits. So we will try to learn how to handle parallel circuits in our present class. Learn first how to solve this. Now you have two similar bulbs rating 100 watt, 50 root 2 volts are connected in series as shown in figure. When frequency of the source is varied, brightness of bulb B2 changes. B1 will not change. Why? Because B1 వాళ్ళందు కూర్చోబెట్టా చెప్ప అందరినీ పిలు ఏం చేస్తారు నేను కూర్చోబెట్టాలంటే వాళ్ళందరినీ కూర్చోబెట్టాలి. It is observed that 50 Hz frequency, both the bulbs have same brightness. Select the correct alternatives. See, in parallel circuit, what is your fundamental reference is voltage is your fundamental reference. For example, for bulb 1, the phasor will be V, and the phasor for VB1 is also like this. Why? Because it is a pure resistor circuit. Any doubts on this? Any doubts on this? Next. Now try to please understand. This is V again. As per your information, 50 Hz. F0 is equal to 50 Hz is considered as resonance. How do you know that that is resonance? How do you know that is resonance? How do you know that is resonance? Question non-mali question adigo. Next. How do you know that is resonance? Cancel అయిపోవాలి. So therefore, in this VB2 at F0 is equal to 50 Hz. Right. A is a common sense question, which is not required too much of information. In fact, when their currents are same, obviously, when current in both the bulbs will be in same phase when both have the same brightness. Correct. Next. And one more important point, you know the resistance of the bulb. The resistance of the bulb is 100 watt into 100 watt by, you said 50 root 2. Sorry. 50, because resistance is equal to P square, V square by P. 50 into 50 into 2 by 100. 50 ohm. Now the question is, at this situation, First of all, I see nothing very serious. It is pure resistance circuit. Entire thing is resistance circuit. So therefore, I RMS value through the bulb 1 is simply 100 by root 2 times 50. 100 by 52 root 2 amps. And remember, this is the same RMS value through bulb 2 because situation is the same. And it is like simple resistor circuit. Because in both the cases, current phasors are also same. Why? Because in both the cases, current phasors also same. I1, I2. Both the cases, current phasors are also same. So therefore, they will simply get added up. I1 plus I2. So root 2 plus root 2 is 2 root 2. So therefore, current through the source will be 2 root 2 as when both the bulbs have the same brightness. B1 will be more brighter for all frequencies except 50 Hz. అరటిపండు ఉడిసిపెట్టి నోట్లో పెడితే ఎట్లా ఉంటుందో అలా ఉంది. But still, any student having doubt on this, please ask. Any student, if you have doubt on this, please ask. I repeat, any student having doubt on this, please ask. Next. First, we will deal parallel type circuits. The second question is a parallel type circuit. This is a parallel circuit again. You want currents. I can do this problem in two different ways. I will try to do this problem in two different ways. Problem method 1, phasor approach. Usually I'll do in phasor approach. So when I am doing phasor approach, series, what is common? What is the reference? Current phasor is a reference. Whereas for parallel, what is the reference? Voltage. Voltage phasor is the reference. Now here you have a voltage phasor like this. If you take IR, this is the current through the resistor, which is the same as in the direction of the voltage phasor. Whereas this is the voltage phasor, and this is how you will have current phasor, 90 degrees. This is again the voltage phasor, and it is an inductor, pure inductor. So therefore, this is how you will have the current phasor. So overall, you can see that the peak value of current through the AC source is what you want. So what is a normal understanding about this particular part is what you want is the resultant current actually. You want the resultant current. The resultant current is IC minus IL. I am assuming like that because no big information was given to me. I am assuming it like that. If I am wrong, that gets corrected in the answer. I'm assuming like this. Square plus IR square is the resultant current. This is the resultant current, which means this is your voltage phasor. Maybe this is your current phasor. What is this current? The drawn current from the source. So clearly, what you want is the peak value of the current through the AC source, right? How to write VC, by the way? IC is nothing but V square by VC. 1 minute. IC minus this thing, you can write it as IC is omega C into V minus 1 by omega L into V square plus V square by R square, which is equal to I. In fact, they are asking you about this, but that is RMS. If V is RMS voltage. So I is V times 1 by R square plus omega C minus 1 by omega L square. That's all. So I try to see which is relatively matching. So B is matching. See, when they have given V omega, when the peak value of the current through the AC, actually they have mentioned that V refers to the peak value. Automatically I refers to the peak value. V is VRMS and I is IRMS. Now I am asking you again, do any student have doubt on this? I am asking you again, do you have any doubt on this? I am not giving you any guarantee that current leads. I am assuming IC greater than IL. If IC greater than IL, this is the picture and this is the phase difference. Any doubts? Boys and girls, any doubts? Sure? Everyone in the class? మరి నువ్వు వింటున్నావో లేదా నాకు డౌట్ కూడా వస్తుందిరా బాబు. ఏమో నీ ప్రపంచంలో నువ్వు ఉంటున్నావు. రైట్. We don't have space. Then again, another parallel circuits. They are two. One is LCR, the other is RLR. Okay. Now please try to two identical incandescent light bulbs are connected as shown in the figure. Both are LCR only. RCR. Okay. Right. The other one is LC. LR. Okay. Bulb 1 is an RC line and bulb 2 is an LR line. Right. Now what is happening over here? Now you want the applied voltage. Current through IR.
ఇప్పుడు ఒక దాంట్లో ఆర్ ఇంకా బల్బ్ B2 ఉంది కదా సార్, వాటిని సిరీస్ లో పెట్టుకోవచ్చు సార్ దాన్ని ఈ క్యాలిక్యులేషన్స్ కోసం.
పెట్టుకోవచ్చు. I told one more point, no, I forgot to inform you. In the same question, the impedance can also be determined in a different way also. It is like 1 by Z is equal to 1 by Z1 plus 1 by Z2 plus 1 by Z3. 1 by Z1 is R. 1 by J into omega L plus 9. J into omega L plus J into omega C. So you can write this as 1 by R minus J or J times minus omega L. Okay, that's 1 by Z is a complex number for you. So you want current as voltage by Z. So voltage and 1 by Z magnet, 1 by Z modulus value. So 1 by Z modulus value is 1 by R square plus omega L square. See, this is method 2, right? Now here also you can use any method. Now, what is same brightness means same current is what required. Same current means same impedance is what required. Okay. So how do I know that they have the same impedance? So what is the impedance of the first circuit? Z1 is R plus R bulb plus minus one by omega C. Any doubts? Similarly, Z2 is R plus RB minus 9 plus J times omega L. Here, the real part of the complex number in both the cases are same. To have the same modulus of impedance, the condition required is 1 by omega C is equal to omega L and F is equal to 1 by 2 pi times root LC. That's it. Done. Any doubts? Okay. How many have done these two questions? This one as well as this one. Right. So next week onwards, our thumb rule is all the students are not required to do this class test and all that. Almost, I think this is done. When modern physics starts, all the students don't do class tests. Just to do volume, you just do the basic class-based discussion questions. EM waves. So we will deal both the questions. I can handle this question here only. The effective current through the source. Again, my reference is V C type, both the sides. My reference is V and R in phase. We will take this as I1 for our convenience. We take this as I2 for our convenience. Unfortunately, what is that we have is XC is known, XL is known. As per the first dynamics, I1 is like this. As per the second dynamics, in the second row, which we call as I2 voltage, and basically what is the nature of that line? Inductive. Inductive means current lags. Right. So what is the resultant? You have I2 like this, I1 like this, and this is the resultant current. So how to find I1? I1 is simply 200 by 100 because R, 2 amps. So which means 4. I2 is again the same. Difference is 100. 200 by 100 to 4. So it is 2 root 2 amps. Even I can give you the phase angle also 45 degrees. Any doubts? This is a good question.
The patterns.
So what is happening most of the time? Why you are not scoring well in that? What I personally assume is you are trying, not getting idea, and the next source is either to go through solution or problem solve. And unfortunately, both the channels are not available while you are writing examination. That is the only problem. This is a very famous question also. For a while, you assume that this is a 0 volt for a while. Now what is happening is that now I will represent the main voltage as V, and this vector is VA, exactly half of the V. Any doubts in this expression?
And across this total left and E between partner and V and
Mhm.
and the point key here and across resistors capacitor across V and E total left and key between and the part key.
What is the above row? What is
This is
this row? Then
and it's in phase with it. And VM represent this VR was the
VA means VA minus V0. కరెంట్ ఎలక్ట్రిసిటీ అయిపోయి
అంటే బిఆర్ఎం రాస్తే తెలుసు.
కరెంట్ ఎలక్ట్రిసిటీ అయిపోయి కనీసం 4 వారాలు కాలే, 6 weeks కాలే. ఇలా ఉంటే ఏమవుతాయి క్యూములేటివ్ ఎగ్జామ్స్. రైట్, నెక్స్ట్. See the other part. For the second part which you are applying, we try to please understand here. This will be the direction of VL. Wrong. 1 minute.
Yes.
That will be the direction of current through the inductor, because that is inductive circuit. That is inductive circuit. Current lacks the main voltage VL. There is a drop across R naught. See, 1 minute. Here I'm doing mistake. 1 minute, 1 minute. I lost focus actually. I lost focus. This is the current through the inductor, and this is the drop across VR. And this is the drop across VL. That's it. Okay, right. What do you want basically? VA minus a VB. According to me, one vector VA is like this. Another vector VR naught is like this. If you want the sum, this is the sum. That diagonal represents sum. But you don't want this. You want difference. Means you want the vector sum of these two vectors. Those two vectors. Suppose if this angle is 5, and this angle will be 180 minus 5. Okay, so you want VAB, which is nothing but under root VA square VR naught square plus 2A VA VR naught cos 180 minus 5, which is nothing but V square by 4. Because you know VA is V by 2. Now what is VR naught? But try to please understand. We took this as 5. So VR naught is V cos 5. That's all. Any doubt?
Secant. No, you secant.
Sure. Why it is secant 5? V is the resultant of two voltages. And by the way, this angle is 90. Therefore, V square cos square 5 plus 2V by 2 V minus cos 5. minus cos square phi. Correct? This cancel. This cancel. Finally, V by 2, which is the same as VA. Now tell me, what are the factors affecting this? Now you go to the question. VAB does not, there is no omega term in this. There is no R term in this. It is simply VA minus VA. Now tell me VAB will increase or increasing or not? Wrong. VAB have no influence with the value of R naught. That's all. Any doubts? It's a very famous question. You have this question even in Pathfinder also. Do you have any doubt on this? Boys and girls, do you have any doubt on this? Boys and girls, do you have any doubt on this? Ram Karthikeya, you are thinking something, ask me right now.
BB అనేది B మైనస్ ఎర్రర్స్ మొత్తం రిజల్టెంట్ ఒక B కదా సార్ అంటే BLA ఫైనల్
వాడు ఏమడిగాడు నన్ను ఒకసారి వాడు చెప్పు. ఇలానే అడుగుతాడు. అది చెప్పాలా? ఎంత అసమైన క్వశ్చన్ అడిగేది. సరే ఏం చేస్తా కర్మ. నెక్స్ట్ క్వశ్చన్. I think this is a simple question. I will do it here only. Impedance of the circuit is, you can do it in two ways. My choice always is phasor. Always phasor. Now this is the main voltage. 2 ohm is what you said. Obviously current will lead here. IC. Whereas the other case, this is the main voltage, that is the inductor. Therefore, this is IL and this makes an angle 45 degrees. How do I know that it is 45 degrees? Reactance and resistance are the same. Right. So you have IL, you have IC. So what is the current? I know IL also. How do I know IL? IL is nothing but V by root 2 amps. Whereas IC is V by 2 amps. Any doubts? I repeat, IL is V by root 2 amps. IC is V by 2 amps. Pridhiman, how you got V by root 2 amps? Right. How do you got IC as V by 2? Z is already given. 2 ohms here. Next, you want the peak value of impedance of the circuit is what you want. Simple. No, nothing wrong. How to get impedance of the circuit? Now the question is, you have ICL, you have IL. The resultant current is IC minus తీసుకోండి IC minus IL by root 2. IL by root 2. Fortunately, IC minus IL by root 2 is 0. So finally, in the entire circuit, the main current is V by 2 amps. The main voltage is V. So therefore, Z is equal to V by 2. And what is the nature of the circuit? The whole circuit. ఎలా చెప్పావు కెపాసిటీ ఒకసారి చెప్పవా ప్లీజ్? ఏదో చూసి చెప్పేసావు, రేపు ఎగ్జామ్లు ఇట్టనే చేస్తావు, మమ్మల్ని ఆయన నుంచోబెట్టి దొబ్బుతాడు కూర్చోబెట్టి. ఎట్లా చెప్పావు కెపాసిటర్ అని? అట్టా చెప్తారా? ఎట్లా చెప్పావు కెపాసిటర్ చెప్పు నాకు ఒకసారి. ఆ కాంపోనెంటే క్యాన్సల్ అయిపోయింది. ద రిజల్టెంట్ కరెంట్ ఈస్ ఇన్ ద ఫేజ్ ఆర్ ఇన్ ఫేజ్ ఆఫ్ వోల్టేజ్. అప్పుడు అది ఏ సర్క్యూట్? అది నువ్వేమని పెట్టేవాడు మామూలుగా అయితే ఎగ్జామ్లో? ఇలాంటి మిస్టేక్స్ మేమే కాళ్ళు పట్టుకోవాలా? పట్టుకుంటారా? సంకనాగిపోతా, అర్ధాయుష్ వస్తుంది నీకు. ఆ ఎలర్ట్నెస్ ఇలా పక్కకు తప్పుకున్న పోతుంది. వాట్ ఈస్ ద నేచర్ ఆఫ్ ద సర్క్యూట్? నువ్వు కూడా వింటల్లా బాబు, ఆ రెడ్ టీ చొక్క సరిగ్గా వింటల్లా ఈ మధ్య. మార్కులు కూడా రావటల్లా నీకు. నేనేం అడగటం మానేశాను నిన్ను, అందుకే చూడాల. నువ్వు వింటల్లా అంటే నీకు నచ్చినప్పుడు వింటున్నావు, ఇప్పుడు వింటున్నావు, మామూలుగా వింటల్లా. రోజు నేను చూస్తున్నాను. నేను 5 వరకు మాట్లాడతా, ఇంక మిగతా వాళ్ళు చదివిపోయినా. That's all. We got impedance of the circuit 2 ohm current. A peak value of current through the resistance. So, this is one mistake which you will do. Peak value of main current కాదు మేము వాళ్ళు అడిగేది. పీక్ వాల్యూ ఆఫ్ ద, అంటే ఇలాంటివన్నీ ఎందుకు తప్పులు చేస్తామంటే బాగా వచ్చు అనుకున్న క్వశ్చన్స్లో ఎక్కువ తప్పులు చేస్తాం. ఎందుకు చేస్తాం? క్వశ్చన్ పూర్తిగా చివరి వర్డ్ దాకా చదవం. ఇప్పుడు ఆల్రెడీ కరెంట్ కట్టేశాను, నాకు ఎంత వచ్చింది? V/2 వచ్చింది కరెంటు, మెయిన్ కరెంటు. ఇప్పుడు మీరేంటారు పీక్ వాల్యూ ఆఫ్ ద కరెంట్ అని అడిగారు అనుకోండి, మీరేం చేస్తారు? 100/2 చేసి 50 అని చెప్తారు. రాంగ్. 50 కాదు, మెయిన్ కరెంట్ కాదు, త్రూ రెసిస్టెన్స్ ఎంత అని అడుగుతున్నాడు. ఇప్పుడు దాన్నే ఉంది పైన సర్క్యూట్లో V/√2 IL V/√2 అంటే 100/√2 50√2 అయిపోయిందా లేదా? సరిగా చెప్పేలా 50√2 వచ్చిందా? IL అంటే ఈ దీనిలో పోయే కరెంట్. IL అంటే V/√2. V ప్లేస్లో 100 తీసుకుంటే మీరు దేనికి చెప్తున్నట్టు ఆన్సర్? పీక్. కాస్ 100/√2 ఈస్ 50√2. యావరేజ్ పవర్ సప్లైడ్ ఏముంది? సప్లైడ్ బై ద సోర్స్ అడిగాడు. ఏముంది? మనం చాలా ఈజీగా చెప్పచ్చు. యు నో కరెంట్, పవర్ ఫ్యాక్టర్ ఈజ్ 1. సో దేర్ ఫార్ కరెంట్ P average is ERMS IRMS. PRMS వచ్చేసి 100/√2. IRMS I పీక్ అయితే ఇప్పుడు ఎంత కట్టారు మీరు చెప్పండి? V/2 50. I పీక్ అయితే, IRMS అయితే √2 50. యావరేజ్ పవర్. Riddhiman, you have doubt in average power. No, you have doubt, it seems.
I had, sir.
You got it self-clarified. Good. Otherwise, you'll come later on. So I don't want to delay anything. Just instantaneously get it clear. Hmm? Hmm. This is the most repeated question. Most repeated question. I'll take some time because it will kill lot of time if I go right now. We'll see other questions. Parallel circuit based questions. Yes, I'll close this here itself. No issues. Now, are we clear? 12-13 model, can we make it? Work on this right now. So in parallel circuit, what is our reference? Voltage is the reference. So now I am taking voltage phasor here. Why? Because this is easy. That you try. If you don't get, you come to me. Because I don't allow you to do in that method. That is a lengthy method. This is a very easy method. Fundamental method. The phasor. XC you have given 8. RB you have given 6. So very clearly it is a capacitive. Current leads. And I know even angle also. Theta 1. You know what is the angle? Tan theta 1 is equal to XC by RB. XC is 8, 6, 4 by 3. Now you take the other main voltage. Okay. Current lags. Let this be theta 2. Help me in writing tan theta 2. ఇది ఎవరికి మీ బ్యాచ్ J00 ఈవినింగ్ 5 to 6 ఎగ్జామ్ tan theta 2 is 3 by 4. Right. The one is 53. The other is 37. They are mutually perpendicular. So what is the current passing through the inductor? Power dissipated in the circuit. Fine. No, everything you have here only. Current passing through the inductor XL is simply given as IL is equal to V applied alternating source. The total current supplied by the alternate IL square. 1 minute. I know IL square plus IC square is I square. That is 14 square. The one more important point is XC XL same కాదు. How do I know 10 amps? Current passing through the inductor is 10 amps. You didn't give any voltage. IL square.
Total current is difference across total current is total current is the bandwidth resistance.
అవును.
పెట్టుకున్న యాంగిల్
ఏ కనుకోట యాంగిల్ ఎలా తెలుస్తుంది? నీకు 90 degrees అని తెలుసు అంతే.
మనకు ఐఎల్ బై ఇది రేషియో తెలుసు.
IL by
ఐసి రేషియో తెలుసు. మనకి ఇది తెలుసు కాబట్టి
IL by IC reciprocal of the impedances. IL by IC reciprocal of impedances. అంటే IC path impedance ఎంత? 10. అంతేగా. RB square plus XC square under root 6 square plus 8 square under root 10. IL path impedance enter 20 square plus 15 square 25. This is 2 by. Substitute in that you will get IL as well as IC. Okay. శ్రీయజ్ ఇది ఎలా చేసాను చెప్పు.
కానీ వీకోల్డ్ ఐఆర్ వాడారు కానీ ఆర్ఎంఎస్ తీసుకున్నారు. ఆర్ అంటే ఎంపిడెన్స్ ఆఫ్ ఒకటి 30 ఒకటి.
So what is the power dissipated in the circuit? You want resultant current. You have resultant current. I do understand. With voltage, how much it is making, that you want. For this purpose, you require IL as well as IC also. అంతే కదా. What is IL value?
సర్క్యూట్ మనము ఐ అంటే 14 స్క్వేర్ ఇంటూ నెట్ ఇంపెడెన్స్ అని రాయాలి సార్.
రాయొచ్చు. బట్ నెట్ ఇంపీడెన్స్ ఎక్కడ కట్టావు?
అట్లా కట్టుకొని చేయొచ్చు సార్.
చేయొచ్చు. బట్ అలా ఎక్కడ కట్టావు? కట్లా. రైట్.
మళ్ళీ ఐఎల్ఐసి కంటే డైరెక్ట్ ఇంపెడెన్స్
ఏది రాస్తావు? ఎక్కడ రాస్తావు? ఏది? అదే నేను చెప్పేది. నెట్ ఇంపిడెన్స్ ఏదైనా చేయాల్సిందే మొత్తం. సో వాట్ ఐ సజెస్ట్ ఈస్ రిజల్టెంట్ ఐ కట్టండి. ఎలా? యూనో ఐఎల్, యూనో ఐసి. ఎక్స్ కాంపోనెంట్ ఆఫ్ వి కాంపోనెంట్, వి సైడ్ కాంపోనెంట్ ఆఫ్ ఐ పర్పెండిక్యులర్ టు వి కాంపోనెంట్ ఆఫ్ ఐ. యూ విల్ గెట్ 2 values. Resultant current already they have given. You know the angle. You know the angle. So ERMS, IRMS, cos of that angle. So therefore,
IC by IL equal to P by IL IC by IL equal to P by
ఎలా? IL Z of that part, IC Z of that part. IL మీరు ఫాస్ట్గా చెప్పొద్దులేరా, వీళ్ళకి ఎక్కదు. Because they are expecting these steps and you are not allowing me to write this. Now tell me what is IL by IC? What is your doubt there? I didn't determine anything, right?
10
Okay, స్లైడ్ చేసేటప్పుడు మారిపోయి ఉండొచ్చు. చేయలే. IL is equal to IC is equal to 10 amps. ఇప్పుడు current passing through the inductor 4 amps. This is wrong. Power dissipated in the circuit. Now you take this the resultant voltage. IC 53 degrees. The 10 amps makes 53 degrees. 4 amps makes so in the direction of V, what is the resultant current? 10 cos 53. Enta? 10 cos 53. 6 plus 4 cos 37. 6 plus 3.2. 9.2. 10 sin 53. 8. Minus 5 point. Actually, you don't require all this. What do you want? A power dissipated. So this part do not contribute to any power distribution. But we don't know, we know. We don't know we, but we know the resultant current 14. Ah. This is a resultant current that makes some angle delta. Hmm. No, actually, 1 minute. I know IC or I know IL as 4 amps. I know ZL in that path as ZL in that path as 25. So therefore, V is 4 into 25, 100 volt. I don't know whether this is a peak or whatever. I'm assuming that is VRMS. Because you mentioned nothing about that. I'm assuming that is RMS value. So therefore, finally, 9.2 into 100 by 2. Why? This itself is RMS value. And this itself is RMS value of current in this direction. Huh? Otherwise, what they will ask? So the answer need to be 920 watt. ఒక్కసారి option. So it is a 920 watt. But anyway, మీ దగ్గర ఆన్సర్స్ చెక్ చేయండి ఒకసారి. లేదా లేదా ఓకే వదిలే అయిపోయింది. That is the way. I didn't do any mistake in this. I am very. Okay, no issues. Okay, no issues. We will go further. I am just leaving series part to you now. Now this is repeated, right or not? Second question is repeated. So seventh we will do. This we will do. I don't think you require again that model. You may require these models. You don't require these model again. Already done. That's all. Now we'll start from here. A source of current I0 sin omega t with I0 constant, I0 as a constant is connected to circuit shown in the diagram. I think this is in my notes, no? Sure? Actually, some more models to cover. Wait, na? Now you have a current of I naught sin omega t with I naught as a constant and is connected to the circuit shown in the diagram. When you are using AC, voltmeter refers to hot wire instrument only, not like idea O voltmeter, right? You have inductors L1, L2, capacitors C1 and C2 are all ideal. Ideal voltmeter is connected between points A and B. Choose correct options. Same, ante. It draws zero current, technically. For very small omega, problem with small omega, when omega is small. XL behaves like a conductor. XC will behave like infinite resistor. So in that case, what will happen? When omega is very small, what to ignore? The entire path is ignored. If you have doubt, any doubt, please ask. Pakka 11, you need to ignore. What is omega is smaller? Omega small means pakka capacitor part ignore. The only thing that contributes to you is L1. So only current pass through L1 and the resistance of the path is omega L1. And the peak value of current normally what you have given is I naught. The peak value of RMS value of voltage, because your hot wire instrument responds to hot wire instrument responds to the RMS value. So therefore the first part is done. Any student having doubt on this, please ask me right now. Any student having doubt on this, please ask me right now. Any student having doubt on this, please ask me right now. Next. Okay, when A is correct, B is obviously wrong. Right. For very large, omega large means you avoid all inductor paths. You avoid only C1. Done. Remember, this is a very easy question. Circuit will trouble you. SRG book question. I would add this Sandy. Malla meer unko start chadukokanడి. Right. Anyway, this is also easy question. Just go through once. Okay. Anyone having doubt on how many have done this question? Raise your hands. నువ్వేం చేయలేదే otherwise also in that also this question is there. Yeah. You have done. Shreyas no చేయలే ఏ right. I think now you are good at these models. Parallel. Any doubt? Yeah, this one also we have done. ఒకసారి అయినా ఇదొక్కటి చూడండి ఒకసారి జస్ట్ ప్లీజ్ ఉంది కాబట్టి చూడండి అంటారు టుమారో యూ ట్రై యూ పీపుల్ 5 people try pathfinder question. Don't touch pathfinder questions. All pathfinders in my notes just around. Boys and girls. How many have done this question? Raise your hands. You haven't done, still doing. How many did not do this question? Raise your hands. It's the same model which I have done. Same model. So which means I took this as O. Same model. So very clearly upper both are above is LR and below is RL, but makes no difference. See, out of all these things, what you need to understand is that
Current phase.
the phase difference between the current flowing through R1 and R2 is, that's what they want. So you make two different this thing. Right.
So allocate solution.
అప్పుడు అలా చెప్పుకుంటా I won't follow the same method. Alternate. Rashid garu. Right. This is done. You don't require this. I think we need to do this one now. I'll try to close this as fast as I can. ఇదే చేసావా సిరీస్ ఇంకేముంది నేను చేసేది ఇందాకే చేసా అమ్మాయి ఇలాంటివి చెప్పండి రా బాబు సో క్లాస్ టెస్ట్ అనగానే ఐ థింక్ ఇది కూడా తీసేనా చెప్పండి ద అమౌంట్ ఆఫ్ పవర్ డెలివర్డ్ బై అన్ ఏసీ సోర్స్ in the capacitor and resistor R1 of the circuit given below is the amount of power delivered by an AC source in the capacitor and resistor R1. Same model. What else to do in this? Normal model. Normal model కదా.
సిరీస్ కదా.
ఐదు ఎక్కువ వస్తే ఇబ్బంది అవుతుంది లోడింగ్. A DC ammeter and an AC thermal ammeter are connected to a series to a circuit in series. When DC is passed through the circuit, DC ammeter shows 6 amps. Don't ask me what AC ammeter shows. It also shows the same read. Okay. When an AC flow through the circuit, the AC ammeter shows 8 amps. What will be the difference in the final readings of the ammeter if DC and AC flows simultaneously through the circuit? Now my question is, why the problem is 8 amps? Why there is a difference?
ఏసీ రీడింగ్ మారుతుంది. ఏసీ రీడింగ్ మారుతుంది, డీసీ రీడింగ్ మారుతుంది.
AC 6 amps means 6 is equal to VDC by resistance. అవును. When an AC flows through the circuit, the AC ammeter shows. For this, I need to ask you one question. Only AC? Only AC. Why there is a difference? That's what I. Are they different? Source, are the sources different? Now my question is, what is the current in the circuit at any instant? I is equal to V naught plus V naught dash sin omega t by R is the current. What is the RMS value of this arrangement? Integral V naught square plus V naught dash square sin square omega t plus 2 V naught dash sin omega t dt by R square times t. So 1 by R, okay, 0 to t.
Sin square omega t.
ఒక్క నిమిషం జాగ్రత్తగా చేయని నా చేత. V naught square అంతే, V naught square అది ప్లస్ V naught dash square by 2 plus 0. Okay, cool. V naught by R square cool. V naught by R square ఏమని పిలిచాం 6 square. ఇది 10 RMS. ఇందాక RMS ఎంత? What will be the difference in the final readings in amp of ammeters? Obviously, DC ammeter records 6 amps, AC ammeter records 10 amps, and the difference of readings for amps.
So, we not dash by root 2 are this. 8 అంటే we not dash by.
అడుగు ఒరే నువ్వు మాట్లాడితే వాడు తప్పు, వాడు రిలీజ్ అవ్వడు. వాడి మీద నాకు ఏ కోపం లేదు, మీ అందరికన్నా వాడి మీద ప్రేమ ఎక్కువ. కాస్త నోరు మూసుకున్నాను అనుకో, నేను వాడికే మొత్తం క్లారిటీ వస్తుంది. వాట్ ఈస్ దిస్? ఇక్కడ ఆర్ఎంఎస్ అని రాశాను. You got RMS value. Final also you got RMS value. Now my question is, sir, you spoke about a DC ammeter when DC is connected. Why didn't you spoke about the reading of DC ammeter with AC? It shows 0. It shows 0. So, okay. Any doubts? Boys and girls. C. ఆడు అడగరా? చూసారా, నా ముఖం చూస్తే డౌట్ క్లారిఫై అయిపోతారా? Is there anything else you used to ask? Go through.
Simultaneously, DC and AC are flowing, sir. Why DC will remain same on one stage?
Before this, I asked one question. I asked one question before this. What was the question?
Any doubt?
No. What was the question? When AC is passing, what is the reading of the DC ammeter? Right. When both DC and AC are flowing together, the AC component always is reflected as 0 in DC ammeter. DC ammeter respond only to the DC component of the current.
Okay.
And whereas AC ammeter responds to both. Previously, with only AC source, you got 8 amps as the current. But now you got 10 amps as the current because it is responding to both. I intentionally asked you the same question. I don't think you require this. Same which I have done right now. Same, just now I have done how to obtain RMS with the DC sources. Just now I have done. What you are doing now, just tell me. RMS in that case is IDC square plus IRMS square. Correct ena okkar chudandi. Just now we have done. What else you require? Just tell me. Anything else left in this? One question is left. One more question is also left actually. Forget that question actually. For seniors recently I have done. In the given circuit, if the given circuit is a balance, I'll close this after. Okay.